Hello everyone and welcome. My name is Sylvia Liu from eBlocks and I will be your moderator for this session. We will see several demonstrations from 5G ACIA members showcase the use of 5G in a wide range of settings. We will start with a joint demo from Bosch, Nokia and Rottenschwarz, where they demonstrate how 5G performs in a real factory environment. Followed by that, we will hear a tech talk on how 5G can be used to help inspect airport fence in Denmark. And then finally, KETI will bring us to their 5G MEC or Mobile Edge Computing-based smart manufacturing testbed and showcase the solutions they've developed through collaboration with their partners. Now let's start with our first demonstration, which is a combined effort between Bosch, Nokia and Rottenschwarz. And I'm very happy to welcome Dr. Andreas Müller from Bosch, who's also the General Chair of 5G ACIA. Hi Andreas, can you briefly describe the factory automation demo that you will show next?
Yeah, hi Sylvia, thanks for having us, and of course I can. Our short video demonstration has been jointly prepared by Bosch, Nokia and Rottenschwarz, and it gives some insights into the performance that can be achieved with 5G in a real-world production environment. We conducted these tests at our Bosch factory in Stuttgart-Feuerbach. There we installed a 5G standalone private wireless network from Nokia, and then we jointly captured performance results using a radio testing solution from Rottenschwarz. The intent of the demonstration is to confirm that 5G provides the performance and quality of service that is needed to automate and digitalize manufacturing facilities and operations. And to this end, of course, we also implemented some first use cases based on equipment and components from Bosch Rexroth.
That sounds very interesting indeed. And this is precisely the purpose of 5G ACIA, to bring members from different industries together to develop real solutions for manufacturing. So you said the demonstration was done in your facility. Can you please briefly describe the factory and what products are produced there?
Yeah, sure. Our plant in Stuttgart-Feuerbach is one of our Industry 4.0 lighthouse factories, and it belongs to the business unit Powertrain Solutions. That means we are producing parts and components for the automotive industry there. The deployed private 5G network currently consists of 8 small cells. It covers an area of around 10,000 square meters, and all the user data remains on-premise, which is in general very important for us.
Thank you, Andreas. So then what is Bosch's vision of the factory of the future, and what role does 5G play in it?
Yeah, from our perspective, 5G will become the central nervous system of the factory of the future, with the potential to enable unprecedented degrees of flexibility, productivity, and ease of use. In our vision of the factory of the future, only the floor, the walls, and the ceiling of a factory remain static and fixed, and everything else becomes flexible, mobile, and easily reconfigurable. So 5G will connect mobile robots, automated guided vehicles, augmented reality glasses, wearable devices, and much, much more. All this is enabled by an unprecedented performance of 5G, for example, in terms of ultra-high reliability and very low latency, novel features like support for time-sensitive networking, TSN, as well as the so-called private or non-public 5G networks. These put factory owners like Bosch in the position to deploy and operate 5G networks in our own production in exactly the way we need it. However, we are still at the beginning of the journey, and activities like the one in our plant Stuttgart-Feuerbach, together with Nokia and Rottenschwarz, are important milestones on the way towards a more widespread adoption of 5G in the manufacturing industry.
Thank you, Andreas. And now I'd like to welcome Jürgen Merkel from Nokia, also a 5G ACIA member. Jürgen, so the 5G standards that support industrial applications is now on its second release, which was defined in release 16. Already in the past, we've seen 5G industries cases demonstrated from many companies, including Nokia. So my question is, what are the main features you are showing here in this demo?
Hello, Sylvia. Yes, it's true, 5G has been around for a while. For example, at Hannover Messe 2019, together with Bosch, we demonstrated an emergency button on a machine where reliability and latency are of critical importance. This was then based on prototype hardware as well as prototype software, and also based on the non-standalone deployment model of 3GPP. In this demonstration now with Bosch and Rottenschwarz, we are showing real commercial available hardware and software, which is based on the 5G standalone model, which will be the preferred model for the industry to use. Nokia considers participation and membership in 5G Asia as essential in bringing forward the widespread adoption of 5G in the industries. Thank you.
Thank you, Jürgen. And finally, I'd like to introduce another 5G ACIA member, Mike Kottkamp from Rottenschwarz. Mike, now can you tell me what makes 5G different or more challenging to test in a factory than other wireless technologies?
Hi Sylvia, indeed there are challenges for any wireless technology that is deployed in an industrial environment. This is mainly because we face very stringent requirements in terms of availability, reliability, as well as stability of the network and its performance. Additionally, specific KPIs are more important in private industrial networks compared with public deployments. As an example, latency is a key performance indicator for industrial application, which requires dedicated or at least adapted test solutions. Obviously, at Rottenschwarz, we actively participate and also leverage the 5G ACIA discussions to optimize our test solutions, as you will see shortly. However, and even more important, we do operate own factories. Most of them are located in Germany. Therefore, we engage early in this ecosystem in order to deploy our own private 5G network, actually also based on Nokia infrastructure. We are active for decades in cellular communications, providing test solutions. But this is the first time we became an adopter, indeed an operator of such a network ourselves. Along with the experience we make, we expect this initial deployed network to evolve, adding enhanced functionality and covering additional sites.
Thank you very much, Mike. Now let's see this joint demonstration of industrial factory automation with 5G from Bosch, Nokia and Rottenschwarz.
Bosch, Nokia, and Rottenschwarz, as members of the 5G Alliance for Connected Industries and Automation, present a practical demonstration of industrial automation over a 5G standalone private network. 5G performance measurements were taken in a real-world production environment in Bosch's Industry 4.0 Lighthouse factory in Stuttgart-Feuerbach, Germany. It proves that 5G can provide the performance, reliability, and quality of service that is needed to automate and digitalize manufacturing facilities and operations. The real-world factory environment used in this demonstration includes Nokia Digital Automation Cloud 5G standalone private network solution. It is comprised of 5G NR small cells and a compact edge cloud server that provides the 5G core functions and supports industrial applications and services. Bosch Rexroth's Active Shuttle, a self-navigating autonomous transport system. It is connected to the 5G private network and receives, for example, routing instructions to deliver parts and material on the factory floor. A Bosch 4K predictive artificial intelligence of things video camera supporting mobile broadband applications. And the Rottenschwarz 5G measurement solutions for deployed networks. It is based on a passive network scanner and an active device which collects the RF parameters and the KPIs of interest for an established data connection. We have all heard of the theoretical performance metrics that 5G can achieve: gigabit speeds, millisecond latencies, 6 nines network availability, greater coverage, and massive machine connectivity. But what is the performance of 5G in a real-world factory environment? Can 5G become the universal industrial communication standard for the factory of the future? The test cases presented in this demonstration will provide real field results to answer some of these questions. Wireless coverage is important in a factory where production area can be quite large, as is the case in Bosch's industrial 5G testbed at its Feuerbach facility, which is 10,000 square meters. The factory floor is equipped with lots of machines and equipment with metallic surfaces that can impact the wireless coverage. This test case measures the absolute 5G signal power levels received at varying distances from the deployed small cell. Measured values in excess of -80 dBm indicate very good coverage conditions. At the same time, the background noise and the potential for interference in the factory environment is checked. To do this, we measure the ratio of the strength of a 5G signal to interference and background noise. The so-called signal-to-interference noise ratio, or SINR, at various locations inside the factory. This is what the active shuttle will experience as it moves around the factory floor. SINR is measured in decibels. The higher the decibel level, the better. SINR values in excess of 30 dB indicate a well-deployed and interference-free network. This value is the basis for the achievable data rates that are shown next. Massive increases in downlink and uplink throughput are expected in 5G to support the growing use of video for quality control applications in manufacturing operations. This test case measures the 5G downlink and uplink speeds available to support these high data rate industrial use cases. For the chosen configuration, with a downlink to uplink ratio of 7:3, data rates of up to 900 megabits per second for the downlink and almost 200 megabits per second for the uplink are achieved. Network performance with deterministic latency for strict industrial communications and control is essential for manufacturing assets to become mobile in the factory of the future. This final test case measures the round-trip latency of the 5G private network as seen on the active shuttle. On average, the recorded latency is about 13 milliseconds based on a standard ping test. Future latency improvements are expected with 5G Release 16 and 17 chipsets supporting ultra-reliable, low-latency communications. This demonstration shows the 5G performance of AGVs and other devices connected to a 5G standalone private network in real factory environment. The results for the test cases shown provide solid evidence that 5G can meet the performance requirements that manufacturers are looking for as they build their factory of the future.
Now let's move to another interesting use case and hear from 5G ACI members Ericsson and HMS on how 5G can be used to help inspect Denmark's airport fence.
Hello and welcome to HMS Tech Talks. Today we're going to have a look at an interesting case study involving 5G communication. And it's a very interesting application actually. It has to do with something as science fiction as robotic dogs patrolling an airport in Denmark.
Som det er nu, der kører vi hegnet rundt hele vejen, og der er 8 km hegn. Og vi skal kigge, om der er nogen, der har klippet hegnet op, eller om der har været undergravninger for dyr, der har været hærværk, eller nogen, der har forceret det. Og vi kan jo selvfølgelig ikke køre særlig hurtigt, for så kan man ikke se hegnet ordentligt, hvis du kører for hurtigt.
Hver dag bliver der inspiceret hegn rundt om infrastruktur verden over. Det er på grund af lovkrav om, at man skal sikre sig, at hegnet er intakt. Vi har derfor undersøgt sammen med Launch Technology, om man kan automatisere den her tidskrævende proces. Ved at lade en robot gå langs hegnet og kontinuerligt optage billeder og analysere billederne, så kan vi så få et indblik i, om hegnet skulle være defekt. Til at analysere billederne, der anvender vi kunstig intelligens og et regelsæt, vi har sat op for, hvordan pigtråden ser ud, hvis den er intakt.
I projektet her har vi anvendt vores terrængående spotrobot, og vi har i samme forbindelse samarbejdet med TDC for at se, om vi kan udvide robottens rækkevidde over 5G-netværket. Lige nu står vi oppe i kontroltårnet, hvor vi kan se hele vejen rundt. Så er der forbindelse, så går vi første gang på 5G.
Grundlæggende set, der er 5G 3 ting. Det er højere hastighed, det er højere pålidelighed og lidt kortere latency eller kortere svartider. Det giver os nogle muligheder. Den højere hastighed gør, at vi kan overføre data eller billeddata i højere kvalitet, så vi har noget bedre information at arbejde med og analysere. Så det er ikke længere sådan, at vi er afhængige af, at der er måske et SD-kort på en robot, og så skal robotten færdiggøre, hvad den er i gang med at komme tilbage igen til os. Vi tager kort ud, vi aflæser data, vi behandler data. Nej, men nu kan vi få data i realtid, så vi kan også reagere med det samme. Det vil sige, hvis vi nu går langs med et hegn som det her, så får vi data hjem og kan se, at der er en fejl på hegnet, så kan vi komme ud og gøre noget ved det her nu.
All right, after seeing this, we are of course very interested to know about the technology behind this and how that works. And with me to discuss that today, we have Niklas Backlund from Ericsson and Jens Jakobsson from HMS. So Jens, if we talk about this from the device side, what is it that's actually going on the top of the dog here?
Yeah, so actually what we have on top of the dog is this prototype of a 5G device. So you see this is a quite small device. It has IP65 protection, so it means that it's waterproof. We have an opening here for the SIM card, and then here connect power, and you have Ethernet. And then of course inside it has the 5G radio module, it has built-in antennas, it also has a built-in real-time operating system. So we have this type of device on top of the dog. It connects to the dog, of course, it connects to the 5G network, and then we have the same device in the control tower. And then we use our real-time operating system to build a secure tunnel between the dog and the control tower, so that we can control the dog in real time.
Niklas, can you tell us a little bit about this from the network side? Why was 5G important in the Spot case?
Yeah, I think this connected four-legged Spot robot is a great example of an innovative way that we can use 5G. And it also demonstrates in a good way what 5G brings, I would say. So first we have coverage. We are no longer restricted by Wi-Fi and the limited coverage we would get out of Wi-Fi. So for example, here in Denmark, we have built a nationwide 5G network. Now the Spot could virtually go anywhere in Denmark as it is today. Secondly, 5G also makes it possible to create, you could say, private networks on the public network. So there's no need to build a dedicated network to actually provide dedicated services in that sense. The third characteristic that you would find from 5G is what we normally talk about, and that's the speed and latency. And in this case, what you see is that we can send huge amount of data from robots back to a back office where we process the data. This unlocks a lot of new usage areas as well. I mean, in essence, we don't have to put a lot of processing capacity on the device itself, but we can do a lot with the data in the back office.
Could you tell us a little bit about what other applications you see, similar applications regarding 5G?
Yeah, so if we take the example of a perimeter fence monitoring, it's a very good example, but I think we can stretch that a bit beyond that as well. You could think about the dog now, for example, being used in emergency services type areas, and the robot dog could actually go into an area where we wouldn't like to send in humans, and by that actually saving lives. So I think we can see many innovative cases where this robot could go beyond by connecting it to 5G.
Excellent. Okay, thanks very much for joining, guys.
Excellent. Now let's see the next demo from 5G ACI member KETI to discover what they've developed in their 5G MEC-based smart manufacturing testbed with their partners. Now let's have a look.
이런 다양한 IT 기술, OT 기술의 융합을 굉장히 중요시 여깁니다. 그리고 또 이런 것들을 각자 기업들이 맡고 있는 현황에 따라서 어떻게 적용할 수 있는지 이런 부분에 대해서 논의를 각계각층의 기업들과 하는 것을 좋아합니다. 저희 공장에 한번 오셔서 어떻게 스마트 공장을 내가 만들 수 있는지
다양한 솔루션들을 소개하고 있습니다. 스마트 제조 혁신센터와 홈 프로젝트를 진행하면서 하나의 스마트 공장을 완성하기 위해서는 다양한 회사의 협력이 중요하다는 것을 알 수 있었습니다.
사업을 시작하면서 어디서부터 시작해야 될지 좀 막막했는데요. 센터에서 여러 업체들과 협력하며 그 길을 찾은 것 같습니다. 앞으로도 센터에서 여러 스마트 공장 기술을 도입하여 고객에게 최적의 솔루션을 찾는 데 최선을 다하겠습니다.
공장에서 생산된 제품 외관에 생긴 불량을 자동으로 판정해주는 시스템으로 SK텔레콤이 제공하는 5G, AI, 모바일 엣지 컴퓨팅이라는 세 가지 혁신적인 기술을 활용한 솔루션입니다. 제품 외관에 생긴 불규칙적인 스크래치, 찍힘 등 불량 이미지 데이터를 획득하기 위해서 이 센서는 조명 조건을 다양하게 변경해 여러 장의 고해상도 사진을 촬영합니다. 대용량 이미지 데이터는 SK텔레콤이 제공하는 5G 네트워크를 통해 5G 기지국 가까이에 있는 MEC라는 모바일 엣지 컴퓨팅의 보석으로 업로딩됩니다. MEC에서는 딥러닝 학습으로 만든 AI 판정 모델이 5G로 업로드된 이미지 데이터를 보고 양품인지 불량인지 스스로 판단합니다. 그리고 그 결과를 5G를 통해 다시 공장에 있는 자동화 로봇으로 전달합니다. 공장에 있는 자동화 로봇은 AI가 판정한 결과를 받아 실시간으로 정상 제품과 불량 제품을 분류합니다. 머신 비전에 적용한 SK텔레콤의 5G, AI, 그리고 모바일 엣지 컴퓨팅 기술은 대한민국 제조업의 경쟁력을 좀 더 높여줄 수 있는 혁신적인 기술입니다.
That's great. And this brings us to the end of this session. Let me thank again our 5G ACI members, Bosch, Nokia, Rottenschwarz, HMS, Ericsson, and KETI for sharing their interesting and innovative 5G use cases. We have a fantastic collection of use cases and demos from 5G ACI members at this year's Hanover Mess program, so do please stay tuned, and there's more to discover in the next sessions. Bye for now.